Hi Stats class, this is a homework problem for your 8.3 homework set, and in it we're doing a hypothesis test. So we're told that there are 416 green peas and 150 yellow peas in some sample, and we're doing a 5% level of significance to test that 27% is the true population proportion of yellow peas in the offspring. So what we're doing here now, this is our sample. So 150 are yellow, and if we divide that by the total, which the total would be 150 plus the 416 together, so they both are in our sample, and we get this number. So the 26.5%, a little bit lower than the 27%, that's the claimed population proportion. So we're going to test, is that feasible? Is this number that we're getting possible? Is it possible to get such a number if this 27% is true? Now, this number down, this is the actual one. You can see the person missed this when they tried it on their homework, but this is the actual one. And it's right because it has the claim that 27% is in the center of our distribution, and that's what this first sentence up here is saying. 27% is the population proportion, which would be in the center of the bell curve. And now these two up here, H0, H1, you have to have equality in H0, and A, B, and F are the only ones that have equality in H0. So we've already eliminated everything except for these three. And then the reason the other two aren't right is because they have greater than or less than in H1. Claim is the population proportion is 0.27. So these values that we're trying to compute, these are all sample proportions. And the sample proportions, because it depends on what sample you get, they can run a wide interval of possible values that you could get for your sample proportion. But the claim is it's 27% to the middle, so most of the numbers should be in and around that. So what we're doing is we're conducting a sample to see, is this 26.5 number that we're getting over here, 26.5, is that, this would be 27%, is this far enough away to say that this is probably not true? So because we're not told whether we're testing if it's above or below, we have to do what's called a two-tailed test. What a two-tailed test would do is it's kind of like a mirror image. We're a half a point percentage point below, so we'd also be half a percentage point above when we do a two-tailed test. And we're trying to determine the area of both of these tails. And if the area is too high, if it's above our value of alpha, which is 0.05, if that area is above 0.05, then we don't have enough information to say, okay, this is probably not true. But if the area were really low, if we were way out here, barely in any of the tails, then we're far enough away from the claim to say that the claim is probably not true. So let's illustrate it. Let's go through and come up with our numbers. So this was the correct one. Again, it's equal to because we have to have equality for the claim. The claim is that 27% will be yellow. So the proportion is 27%. And the null hypothesis here is not equal to because we're not told whether it's above or below. It doesn't say anything about that. Alright, so anyway, that's going to be our information. Now, to get the test statistic, again, the easiest way is to just run the test. So the way you run the test on the calculator is stat test. This is a 1 prop z test. How do I know this is 1 prop z? Because all these choices are p, and p stands for proportion. Right, and it's a hypothesis test because we see words like hypothesis, test statistic. So that's a hypothesis test. So we want option 5, 1 prop z test. Alright, the claim is p equals 0.27, so 0.27. X is the number of successes we have, so that's the yellow peas. So that's 150. N is the total number we sampled. Now some were green, some were yellow, so we have to add these together. So again, we can do it on our calculator as we're typing it in, or we can have it added together ahead of time. Okay, your calculator will switch it. And then this symbol, the second part is the alternate hypothesis, or H1. So it's saying the proportion is not going to be equal to this number. That's going to be right because that's what we got down here. But again, it doesn't say anywhere that it's greater or less than. So because it doesn't specify, we use not equal to. If it does specify, if it says test the claim that it's less than 27%, or test the claim that it's greater than 27%, then we would pick the one that goes with that. But because it doesn't say, or if it says something like different than, then we would use not equal to. All right, calculate. The very first thing we're going to see is the test statistic. Okay, it reminds you of the test you ran. There's our test statistic. So negative 0.26 to 2 places, negative 0.27. All right, and then what's the p-value? That's the next thing down. This is the proportion. This is the 150 divided by the 566 right here. But this is the p-value. Okay, right below the test statistic is the p-value. So 0.7, we want 4 places, so 7895. All right, and then the conclusion. The way you conclude these tests is you look at your p-value, you look at your level of significance. If p is less than the level of significance, you would reject the null hypothesis. But if the p-value is greater than the significance level, which it is in this case, we're going to fail to reject. Okay, fail to reject because the p-value is greater than significant level. That's our answer. This one says fail to reject because the p-value is less than, and that's not true. Okay, but we do need to fail to reject. All right. What's the final conclusion? There is not sufficient evidence. Anytime that you fail to reject, that means there's not sufficient evidence to warrant rejection of the claim that 27% will be yellow. Okay, see, this one has that direction again, less than. If that were the initial guess, then this would be correct, and it would be less than. But because it's not equal to, we can't have that direction in there, the less than or the greater than. So just a kind of a recap of what these numbers have to do with this picture. So the p-hat, the 0.265, this was the actual test statistic that we came up with, the 26.5%. So this 27, we didn't actually come up with this, but because we selected not equal to in our original test, we have to consider anything that would be this far away from the claim below. So this is what we actually saw, so that far away below, or possibly it could have been that far away above, because it was just a random sample. So it could have been below, it could have been above. But this is how far away we were with our 26.5 in our sample. So again, not equal to creates a two-tailed test, so we have to have like a mirror image on the upper side of the mean, or of the claimed proportion, which is the mean of the p-hat distribution, but we have to be on both sides of it. So this, all this area together, the blue and the red together, is the p-value. All right, if we came up with both of those areas, and the test statistic, the negative 0.266, that's if we zero this out, if we made a standard normal distribution and made the middle, the 0.27, if we standardized it and made that 0, then this 26.5% from the actual distribution would be the negative 0.267 roughly in the standard normal distribution. What was it again? 0.267. That's our test statistic. So in the standard normal distribution, we're dealing with the mean is, the middle is 0 and 0.267. That's our number. Okay, but again, we also have to consider positive 0.267 and everything to the right of that. So if, just again to show you our p-value, remember 0.789 is our p-value. That's what we're saying the area is of these two regions added together. This is the standardized version of that, of what we're actually doing in a z distribution. Okay, this was all the different possible p hat values. These are the standardized versions of those. So if I did normal CDF, and then down here in the bottom one, negative 999, comma, to negative 0.267, and hit enter, that's that region down here below. If I double that, because of the symmetry, I would get this region and that region together, and there's that 0.789 number. Okay, it's the region, both of these regions together. So that's what the value, all the different values that we saw when we ran that test, what they all represented in this picture. Okay, so that's what we're trying to do, is to come up with how likely is it to see what I just saw. And the reality is, if 27% is the actual percent of yellow peas, then seeing 26.5% is not that rare. All right, it's saying that could happen. You know, that something that rare or more rare could happen around 79% of the time, which is more than 3/4 of the time. So it's not rare at all. So there's no way we would reject that. This would have to be a very small number for us to reject it. Now, hypothetically, this wasn't the numbers, but just hypothetically say, what if we saw, instead of 26.5%, what if we did a sample and we ended up with something like 5% of them were yellow. All right, well, that's a difference of 22 percentage points. So add 22 percentage points there, and we've got 0.49 way up here. Now, if I ran that test, just to show you the difference, so let's say 566, and let's say we got 22% of 566. Oh, sorry, not 22%, 5%. 28.3, so I'm going to round that to 28. And now I did it. Alright, I get a z value that's negative 11, and my p value, look at that. It's got 31 leading zeros. It's virtually zero. So it's saying that if this is true, the 27% is true, and this is what you got in your sample, what that's basically saying is this can't be true. You know, there's the probability of seeing 0.05, if this is true, is 0.000, 31 zeros, and then a 3, which is virtually zero, which means there's no way that could happen. All right, so that's the interpretation of what all this stuff means if you reject a claim. If this p-value is extremely small, smaller than your alpha, your level of significance, then you're going to reject the claim, because what we're seeing is extremely rare. This shouldn't be happening. But in our example that we just saw, it wasn't rare at all. It happened more than 3/4 of the time, so we're not going to reject this claim. This could very well be the center if we're seeing something that happens 3/4 of the time.